All right, everyone. So here we are on our last and final lesson, which is on the Unit 7C, which is on factoring patterns. So this is the last and final lesson that we have whenever we're doing factoring patterns. What's going to happen is you will notice that it states right here that up until now, factoring has been a bit organized. What it means is it has given us, up until now, it has told us exactly what factoring method we want to use. All right. Now, what we're going to do here is we're now going to be mixing these up. So we want to follow the guide, the 3 steps below, to help us. So the very first thing that we want to always do, which I've told you in the past, is you always want to check for a GCF. So you always want to check to see if there is a greatest common factor that you can factor out of each term. The next step is you then want to check for one of the following patterns and factor if possible. If it's a binomial, you want to check for difference of squares, meaning you are subtracting 2 perfect squares. Or a basic trinomial, which we know a basic trinomial is when our leading coefficient is 1, so talking about A is 1. The slip and slide method is when we have when A is not equal to 1, so it's something different. And then we have the grouping method, which is when we have 4 terms. And then once you use one of those methods, you always check to see if there's something that needs to be factored again, because you could be factoring more than 2 times in whenever you're factoring. Okay? So, looking here, you will see that I have not done number 1 and I have not done number 2. Okay? I think actually though I am going to do number 1. Let's do that. Okay? So, number 1, because there is something close to number 1 that I'm going to pause and have you do. So, looking at number 1. So, number 1 states that we have here, we have 28a squared b minus 63b. So the first thing that we want to point out is both of these do have numbers. So the first thing we want to do is we want to determine if there is a GCF. So we want to determine what is the greatest common factor between 28 and 63. So when we do that, we know that 28 is 1 times 28, 2 times 14, and 4 times 7. We know that 63 is 1 times 63, 3 times 31, 4, 5, 6, 7 times 9. Okay? Once we know that, we can then see that our numbers here, that they have 1 in common, and they have 7 in common. So the greatest common factor of these numbers would be 7. So I know that we can factor out a 7. Now, so we know that part of our GCF is going to be a 7. What else do we know? Well, with a squared, if I have a squared, I do not see that we have a variable a in the second term. So there's nothing that we can pull out with a, but we do notice that they both share a b, so we can factor out a b. So our GCF here is going to be, all right, so when we do that, that is going to leave us with the new binomial, so 7b times 7 divided by 28 is 4. And a squared is still there, and the b's cancel. Minus 63 divided by 7 is 9, and the b's cancel. Now that we are done with that, we can see that we are now going to check for, because we did our GCF, so step 1 is done. We now want to check for one of the following patterns. Well, we see that we have the difference of squares. Or we can try to check for difference of squares because we have a binomial. So what we want to check for is, are these numbers perfect squares? So talking about 4 and 9. Yes, they are. Is a squared a perfect square? Yes. So what ends up happening is we can replace 4a squared with the square root of it, which is 2a squared, and then minus, and then the square root of 9 is 3. And so what you're left with is, let me go ahead and change these to some different colors. All right. So what you're left with is now using that pattern for the difference of squares tells me that I take those two factors and I take the difference of them and the sum of them. So our factor here is going to be left with 7b times 2a minus 2a plus 3 times 2a minus 3. Okay? And so, and now looking at those, we cannot no longer factor. So I'm going to go ahead and add that to here so that y'all do have that. So 7b times 2a plus 3 times 2a minus 3. Okay? And so that's what we want to put in here. Seven b times 2a plus 3 times 2a minus 3. And they 7b 2a plus 3 there we go. And there you go. All right. So now I need you to pause the video and go on and do number 8 for me. So now you are doing number 8. All right, everyone. Now that you have done number 8, we are now going to look at number 3. So looking at number 3, here we have x to the third plus 2x squared y minus 4x minus 8y. So here, first thing I'm going to do is I'm going to highlight my x's and then highlight my y's. I see that actually the first thing I'm going to do is highlight my numbers. 2, 4, 8. And now I'll highlight my x's and my y's. Now, you will see that every term does not share those factors. So, there is no GCF here. So, there is not a GCF automatically. So, there is none here. So, but since we have 4 terms, we may be able to factor this by grouping. So, what I want to do here is I want to group these. I'm going to group the first 2 and then the second 2. And I want to make sure I have that and we have the plus sign in the middle. All right, so what that means is I need to find the GCF of x to the third and 2x squared y. Well, that first one only has an x to the third and the second one has an x squared. So the GCF here is just going to be x squared. So that's going to leave us with x squared times x to the third divided by x squared is just x plus and then 2y. Now we have plus, and now we need to factor out negative 4x minus 8y. Well, again, we know that we have that negative there, so we need to factor out a negative. The greatest common factor between 4 and 8 is going to be 2. Or no, I'm sorry, is going to be 4. So, and there is nothing in common between x and y. So our GCF here is just going to be negative 4. And that's going to leave us with x plus, because negative 8y divided by negative 4 is positive 2y. All right. And so you will notice here that we have x plus 2y and x plus 2y. So we can factor out an x plus 2y on both of these. And that would leave us with the x plus 2y times x squared minus 4. Now, we are not done because this right here, we see that we have a binomial. So right here, we can see that we have this binomial x squared minus 4. So since we have this binomial x squared minus 4, this here is a difference of squares because x squared is a perfect square and 4 is a perfect square, and we're taking the difference of those. So bring this over here. So I know that we have our x plus 2y, and then I know I can rewrite my x squared minus 4 as x times x raised to the second. So x raised to the second minus, and then the square root of 4 is 2. So 2 raised to the second. Oops, these are supposed to be pink and blue. Okay. So now that we have that, what I can do is I can rewrite that as, so we would have x plus 2y times, and then we would be left with the sum of x and 2 and the difference of x and 2. So x plus 2 times x minus 2. And that is your factor. So x plus 2y times x plus 2 times x minus 2. And it's probably going to tell me I'm off because of my signs. Okay, don't worry about it, guys. So just know that that is what you get there. I'll go fix it in the thing. I just have one answer showing right now in there. And there you go. All right, so I need you to pause the video and go on and do number 9 for me. All right, everyone. We are now going to look at, so hopefully you were able to go back and do pause and we're able to do number 9. We are now going to look at number 7. And once I do number 7, you are then going to go on and pause and go do number 2. So looking at number 7, what we have here is it says that we have 8x to the 4th minus 4x to the 3rd minus 24x squared. So the first thing we need to do is we need to find the greatest common factor between 8, 4, and 24. Well, we should know that by looking at 4, that the lowest number there is 4. And we know that 4 is a factor of both 8 and 24. So what ends up happening here is we can go ahead and we know that 4 is the greatest common factor of all of those. Now, looking at the x to the 4th, x to the 3rd, and x squared, remember we always pay attention to the actual exponents, and you want to pick the one that has the smallest exponent. So in this case, the x squared is what is going to be our greatest common factor between our x's. So now once we have that, so we can see that our greatest common factor is going to be 4x squared. All right, and now that's what we're going to factor out. So 4 x squared times 8 divided by 4 is going to be 2. And x to the 4th divided by x squared. Remember, when you divide powers of the same base, you want to subtract their exponents. So that would leave you with x squared. Minus, because we have that minus 4 divided by 4 is 1, so that would cancel. And x to the 3rd divided by x squared is just going to be x. Sorry about that, guys. Sorry about that, guys. All right, so then we have 2x squared minus x, and then the last part is going to be 24 divided by 4, which is going to be 6. So we are going to have that minus 6, and then x squared divided by x squared is going to be canceled. And now we see that we are left with 4x squared times 2x squared minus x minus 6. Now we need to actually factor the next part. So we have 2x squared minus x minus 6. So in order to factor that, this is when, since we found our GCF, we can see that we have an a that is not equal to 1. So we're going to have to use the slip and slide technique. So we're going to slip 2 over here, and we're going to do 2 times 6. Well, 2 times 6 is equal to 12, and so that is our new C. Our new C is 12. So that's going to leave us with 4x squared times x squared minus x. And that's a negative 6. I'm sorry, guys. So that's going to be a negative 12. So then minus 12. And now that we have that, we now use the BC method. So in this case, our B is 1, so B is equal to 1, so we need 2 numbers that add up to give us 1, but when you multiply, give you negative 12, all right? So 2 numbers that add up to give you 1, but when you multiply would give you 12. Well, I know that 3 and 4 are 2 numbers that when you subtract would give you 1. So which one of those would give you 1 if they were negative? And that would be 3. So therefore, our factors, our new factors of our new trinomial that we have is going to be x minus 3, x plus 4. So we have 4x squared times x minus 3 times x plus 4. All right, now what we want to do with that is we now take our original a and we put that underneath our factors, and then we simplify our fractions. Negative 3/2 cannot be simplified, so that is going to leave us with, I'm going to go ahead and bring down that 4x squared times, so that's going to leave us with that 2 goes in front of the x, and we're left with 2x minus 3 times, and 4 divided by 2 is just 2, so we're left with x plus 2. And that's your answer. And so that is as much as we can factor. And so here we would be left with the 4x squared. So remember, we got to go to our Classkick toolkit to get the squared. Copy. Paste. all right, times 2x minus 3 times x plus 2. And it's probably going to state that I'm wrong, which is fine. It's just because we have to switch those around. So just know that. So it's probably x plus 2 times 2x minus 3. So x plus 2 times 2x minus 3. What are you talking about? I'll have to go back and look at that, guys. Let me go look. It should be correct. Let me find my Classkick. Let me go check. Oh, I see what happened, guys. So this here, we wanted this to be -1. Looky there. Way to go, Mrs. Hogue. So since we wanted that to be -1, that means our 4 needed to be negative. So that means that this should have been +3, and this should have been -4. So that means that this is going to be 2x plus 3, and then x minus 2. So that's what happened there. Looky there, guys. Way to go, Mrs. Hogue. So x minus 2, and then 2x plus 3. And there we go. All right, guys. So please pause the video and go on and do number 2. All right, guys. So now that you have done number 2, I now want to look at number 4. You should be able to do number 10 on your own. So I'm going to look, actually, I'm going to want y'all to do number 4 on your own. Let's look at number 6, and that'll be the last one I do. So number 6 here, we have our numbers 24, 6, and 3. So the first thing we want to do is we want to determine the greatest common factor between 24, 6, and 3, which we know that 3 is a factor of all those. So I know that I can pull out a 3. And now looking at that, I now look at, well, I have an x squared, an x, and an x. Well, remember, we want to take the one with the smallest exponent, which in this case is just x. And then we have our y squared, y squared, y. Again, the one with the smallest exponent, so it would be y. So our GCF here would be 3xy. So 3xy. So that would leave us with, so 3 times x times y would leave us with 24 divided by 3 is going to be 8. X squared divided by x is just x, and y squared divided by y is just y. Minus 6 divided by 3 is 2, so minus 2. X divided by x cancels out, and y squared divided by y is just y. And then we have that plus 3, and then x and all those would go away, and we would just be left with 1 here. And so looking at that, guys, I will go ahead and tell you there is nothing else that we could do here to factor this. It would be different if we were in the form of 8x squared plus bx plus c, but we're not in that form, so that there is your factor. So we would be left with 3xy times 3xy times 8xy minus 2y plus 1. Plus 1. There you go. All right, guys, so please make sure that you have completed all of the rest of these, number 2, 4, 5, 8, 10, and 9. And I will actually probably help you with some tomorrow, okay? So just make sure you get those completed. All right, have a great day.